In addition to animation via automatic keyframing, MaxScript supports direct manipulation of controllers and keys, providing the kind of functionality you have in the Max Track View. You can create and assign controllers and manipulate their parameters. For keyframed controllers, you can add and delete and move keys and manipulate key parameters. We'll explore these capabilities briefly now. You access the controller on any animatable property of an object through the dot controller property like this. Here I'm accessing the height controller on box 01 and assigning it to variable C. You can also create new controllers using a constructor, just as with all other Max object types. Here I've created a path constraint controller, setting some of its parameters at the same time. You assign controllers to a parameter simply by assigning to its dot controller property like this. Here I'm assigning a newly created path constraint controller to the position parameter on box 01, which, as you can see, has now been constrained to line 1. You can also access and adjust controller parameters as properties inside the controller using the dot notation property access. For example, here I'm reducing the bank amount of box 01's position controller by 0.25 using the -= assignment operator. You can also use controller assignment to easily instance and copy controllers around. For example, this instances box 02's scale controller onto box 01's scale so that they both share the same scale controller. And this puts a unique copy of box 01's height controller onto sphere 01's radius. The copy function here is the same copy function I used previously to clone scene nodes, but it is a general purpose cloning function that can be used on any Max object. If there is no controller assigned to a parameter, the dot controller property yields the special undefined value, so you can test for this if you need to check. This example tests to see if box's height has a controller by comparing the dot controller property with the special undefined value, and assigns a new noise float controller to the box's height if it doesn't. Most of the default controllers in Max, of course, employ keyframing, and MaxScript provides a number of ways to work with controller keys. You get at the keys on a given controller via its .keys property. Here I'm getting the keys on the height controller on box 02. This gives me a special array type called a max key array, which contains all of the controller's keys. As a shortcut, in the case where an animated property has a keyframed controller directly assigned to it, you can also get at that controller's keys through the .keys property directly on the animated property itself. You access an individual key in these arrays using standard array indexing like this. MaxScript has 3 different key classes: Bezier, TCB, and barycentric morph, corresponding to the 3 kinds of keyframable controllers supported. And each class has a different set of properties and functions, all described in the Max Keys topics in the MaxScript help. All of the key classes share 3 common properties: .time, which is the key's time, .value, which holds the key's value, and .selected, which is true if the key is selected in one of the track views. These are all assignable as well as readable properties. You can move a key around in time by assigning to its .time property, or adjust its value by assigning to its .value property. For example, this sets the value of the first height key to 23. And this for loop loops over all of the keys in a key array and prints out their value and time. Let's see how we might use these key manipulation facilities in MaxScript. Here's a script that sets up a camera with an empty Bezier position controller and creates a new set of position keys based on some data read from a text file. It also sets the tangent type for each of the keys to step, so the camera will jump from location to location. The script defines a function called stepCam, which takes as parameters a target camera and the name of a text file containing the camera stepping data. Here's some sample data in a file called camdata.txt. There are 3 data items per camera step. First, the position of the camera, then the position of the camera's target, and finally the time in frames to spend at that placement. Each triplet defines a new step, and I put each of the steps on a separate line here in this file. So here's a scene with a camera in it ready to animate. I'll call the stepCam function, giving the camera as the first argument and the name of our camera step data file as the second. And now, as you can see, the camera has been step animated, jumping from placement to placement according to the data in the file. Notice that in track view, the key tangent types for the camera position have been set to step. Okay, let's look at the code. The function stepCam is defined to take two parameters, cam and data file. This first section here checks to make sure the camera and target have Bezier position controllers. It adds new ones if they don't, or deletes all of the keys on the controllers if they do. The delete keys function is one of about 20 built-in functions for manipulating keys on controllers, all described in the controller key functions topic in the MacScript help. There are others for adding, deleting, moving, and scaling keys, and so on. Next, I grab the controllers into some local variables, so I don't have to keep typing in the long nested accessor each time I want to refer to them in the rest of the code. The final section implements a loop that reads successive camera steps from the data file and inserts corresponding new keys into the camera and target position tracks. In addition to the key operations, there are a couple of other new things being introduced in this script, including file input and a different kind of loop control. So, the openFile function here opens the file named in its first parameter, which is the file name we originally passed in as a parameter to stepCam. This returns a special value representing the file that I've stored in the local variable f. I'll use this value to access the contents of the file in the rest of the loop. I also initialize a running frame counter that is used to place keys at the right time as the function reads successive step intervals from the file. The loop construct is called a while loop. Instead of taking a collection or range to loop through, it takes a conditional expression, same as the test expression in an if statement. This is evaluated each time around the loop and tells it whether to continue repeating the loop or to break out of it. While ever this conditional is true, the loop will repeat. In this case, the while conditional is basically keeping the loop going until I've read all of the camera data out of the file. It says, while not at end of file on F, do this block. It uses the EOF file stream function, which returns true if all of the data has been read, and false if there's more to read. As with the for loop, the body after the do is repeated. These lines read three values from the file and place them into local variables, corresponding to the triplets of data for each step in the data file. They use the readValue file stream function, which reads the next value in the file each time you call it. Along with openFile and EOF, readFile is one of about 15 built-in functions for reading and writing text files. Recall that the format for each step in the camera data file was 2 3D points and a number. So these locals will contain the position and step values after the reads. Now with the step data in hand, I can add the keys and set them up. The next two lines add keys for the current step to the camera and target controllers I'd grabbed earlier. The add new key function takes a controller and a time at which to place the key. The function yields the new key as its result, which I grab into a couple of locals here so I can set values and tangent parameters in the following lines. I set the key's value simply by assigning the 3D points read from the file to their .value properties. And then I set the incoming tangent types to #step, so we get a step transition as desired. The word step with a hash in front of it is another kind of literal value called a name value, and it is often used as a symbolic parameter in MacScript. The final line in the loop bumps the running frame counter along by the step time read from the file, so that the next key placed in the following repetition of the loop will give the camera the desired time at this step. It started at 0, then will bump to 20, then 50, then 105, and so on, accumulating the step times from the data file that we've read.
The final line in the function closes the file, which tells the system you've finished with it. If you don't do this, it thinks you still want to use the file and won't let you delete it or recreate it outside of MaxScript.
Okay, as I mentioned, most of the MaxScript functions that work on controllers mirror the operations available in the Max track view. In a manner similar to the way the object-level tracks in the track view let you manipulate keys and times for all the sub-objects and subcontrollers within them, many of the MaxScript controller functions can also be applied to higher-level objects or controllers, and they will affect the keys and times in all the controllers nested within them.
The functions that work this way are listed in the MaxScript help topic called Time and Key Functions on Object Hierarchies. These functions are also collection mapped. Here are some quick examples. This deletes all of the keys on all of the controllers nested inside the object $ball, including all transform, parameter, and modifier controllers, and so on. The insert time function moves all of the keys in all of the controllers in all of the child and descendant objects of the torso object across 20 frames starting at frame 10. And this sets the parameter curve out of range type to ping pong on box's position. If box's position was controlled by a position XYZ or a position list controller, say, the out of range type on all of the nested subcontrollers would also be set to ping pong.
As you can see, this is pretty powerful, and I frequently type these kinds of commands into the listener while working interactively in Max rather than opening up the track view to do the same thing.